purpose of this talk is people come up with bugs they find, and they think that perhaps this isn't something I can write a test for because I'm not a kernel developer. Writing kernel tests takes arcane knowledge. It really doesn't. And so what I'm going to do in this talk is go through how our test suite works, how you can write a simple test case for bugs that you come across, and the more coverage we have, the more helpful that is. You might think, well, my bug has been fixed, and this is something that I don't have to deal with anymore. Regressions do happen, and in fact, I just committed a test case yesterday where we had fixed a bug and then it came back. And had we had the test, we could have said, hey, this bug is back, and hopefully find it before we push it out to users. So, today's topics, we're going to cover why you would want to write a test, how you would write a test. It's really easy. Submitting tests to the test suite, and then I'm going to go over our new front end a little bit as well, because I know that some people are interested in that, especially since we have badges now. So, why write a test? The purpose of writing tests is really to find regressions in current upstream. Whether or not you're running the test suite every day, we run the test suite on every single kernel that is built automatically as soon as it comes out of Koji, which means hopefully we can find a regression before the kernel ever makes it to repository and possibly fix it before you ever see it. Sort of. We want to make sure that bugs aren't reintroduced. Like I said earlier, we've had instances where a bug is fixed, and then later another kernel comes out and the bug is no longer fixed. There have also been instances where the behavior is different. It's a completely different bug, but the test would have caught it because the behavior no longer works. Also, we want to find regressions in stable releases. Unfortunately, stable releases they fix a lot of things. They are not necessarily regression free. So by stable releases, I mean right now we are on 3.15. I'm building 3.15.9 right now for Fedora 20. So after 3.15, there shouldn't have been any new features, new development. Occasionally some drivers make their way through. But you have fixes for things, and sometimes when you fix one thing, you break another thing. So the more coverage we have, obviously, the better off we are there. And we do run it as a sanity check before every update is pushed. Every time that we build any kernel, it gets tested. So, what would you want to test? Reproducible bugs. Obviously, if you've got a bug, whether it has been fixed or not right now, if you can do something to reproduce that simply, that's a good candidate to write a test case for. Not something that takes 3 hours to reproduce or those types of things. A lot of times you might find a simpler cause for that as the bug is fixed, and that would be a good way. Sometimes you'll submit a bug, upstream, and when they figure it out and write a patch, they might write a test case in the patch. If you're following that thread, that's a great way to say, hey, I've got this simple test case now, maybe I should write a test for it and throw it into the test suite. Security functionality is always a good thing to write tests for. Even if it's working, you want to make sure it continues to work. And we do have a couple of tests in the suite specifically testing security features. And specific features. If there's a specific feature that you happen to know a little bit about, or you happen to really like the functionality of, that's a good candidate for a test case. Hey, I want to make sure that this continues working. There's a lot of churn in the kernel upstream, thousands of patches per release, so it does mean things can get introduced. So how do you write a test? And the simple answer here is really any way you want. The test suite is essentially a series of, it's a bash harness that goes through subdirectories and runs script, the runtest.sh in every subdirectory it finds in that area. So anything you can call from runtest.sh would be valid. We have tests that are just shell scripts. We have tests that are C code that has to be compiled and then run. You could have Python, you could have whatever you want in there. The only thing that you need to keep in mind is a lot of people are not running a fully installed system. So you want to make sure that either you're not using something that's not going to be on most default installs, or if you are using something like that, that you check and make sure that it exists. it's fine. We have, we want to be able to write tests where, hey, I need this hardware, I need this kernel driver. And that's installed on maybe 10% of systems. You can do that, as long as you were checking to make sure that that driver is actually enabled first when you run the test, and you skip the test if it doesn't. You don't want to fail because it's not there. All your results are reported via return codes. And that makes it very simple to determine pass-fail for the main harness. What happens is if you exit 0, you return 0, then the test was successful. If you exit 3, return code of 3 says that this test was skipped for whatever reason, and anything else is a fail. So I said earlier you can check for the existence of required features, and I'll show you a couple of ways that we do that in the test suite right now in some coming slides. The Git repository that's listed here is the Git repository for those tests. You can grab it, write tests, send patches to our kernel list, or send us push request, check it out, run the test. There is a documentation.txt file in there that really goes through everything you need to know to write a test. So let's look at a simple example. This is a test that's in the test suite right now, and it's really just making sure that there aren't any world writable files in sysfs. There are certain files that we ignore, and so that's what this is, and I didn't include this script. It really doesn't matter. It's more to look at the overall structure of the test. So obviously we just want shell for run test.sh. Anything else, you can have anything else in there, but run test.sh has to exist for a test to be run. So that's the shell. This one doesn't use anything extra. We go through and do a check for something. If we don't find what we want, or if we find something we don't want, then we exit with a -1. That value could be anything except for 0 or 3 and get the same result. And if everything is planned, we exit 0. It's that simple. We have other tests that go through and they've got 100 files in the test directory, and they're compiling. They actually compile the code at runtime. You don't want any binaries in there. Run the test. And then output results. It can get as complicated as you like, as long as it can be controlled by run test. So requirement checking. There's a utilities directory, which has a few scripts in it. Little things that so they don't have to be written every single time. But there's root check, there's module check to make sure that a module is actually inserted and running in the running kernel. There's a couple of others. And I'm probably going to add SE Linux because I've had to use it a few times. But it's not there right now. So here is a simple check. Is SE Linux in enforcing mode? In this actually, the test that this was written for, it doesn't matter because it was checking ABC denials, which means it could be an enforcing or permiss or
Where
do we go from this?
permissive. Yeah. You said enforcing or and
No, there's the one that the one that
Disable.
doesn't
disable,
Yeah.
permissive.
right.
and
Okay,
first, yeah.
right. So permissive is fine. Anyway, we need SE Linux enabled. So we exit out. You can check for anything that you have a common tool to do it on the system, but when we exit with a 3, that means this test has been skipped. It has not failed. There are a lot of them that are root checks because really we can't test a lot in the kernel if you're not root. We ask when you run the test suite, you run it as root. There's a convention in the test suite where you have default tests, which when you do the head run test, then that just runs the default test. And then we have options for, there aren't any tests there yet, but for more intensive tests that are going to take a long time to run, because obviously if you need a 3-hour test run, most users aren't going to want to run that default all the time. And then there's an option for less friendly tests that could possibly cause problems in your system, and you wouldn't want to run them on anything but a dedicated test system. So anything in the default directory should be safe. And any tests that are submitted, that's one of the things we review for. So it shouldn't be a problem there. So how do you submit a test? Getting your test upstream, obviously you've written a new test. It's easy, you're sure that it works. Before you do that though, you need to think about everybody else. What is everybody else doing? If you're running your computer a certain way, SE Linux is a great example. There's people who are running with it disabled frequently. And you need to make sure that your test is going to work either way, right? It's either going to work the way that you're running your system, or it's going to just skip if it wouldn't work on someone else's system. So that's where we do the checks. Once you understand how it's being run by other people, you think everything's good, it's either going to pass or skip unless there is truly a failure, then you can submit it to us at kernel@list.fedoraproject.org. You can submit it via here's a patch and here's my test, or you can submit a Git pull request. Any of those things work. I just actually put in an idea of giving badges out for people who write tests that get put in, so we will be tracking when it goes into Git, it goes into you. But that can be done via pull request, or I can do it when I bring it in manually. And then if it's related to a bug, please reference that bug somewhere in there. A comment in runtest.sh is fine that says this references Red Hat bug here or upstream bug here, just so we have some background on it. And that way, if it fails, it's an easy place for us to look and say, oh, well, here's the background and why this was written, and this is what caused it before. It might help us find a solution again. And like I said, if your test is failing, when you submit the test, if your test is failing because the bug has not been fixed, so it's intentionally failing, when you submit the test, if you would note that makes it a lot easier. That's one of the things we want to keep in mind when we're going through. That doesn't mean it won't get added to the test suite, but we might actually add it in a different directory at that time so that auto test runs it, but users don't see it fail every time. And like I said, you might get a badge for it. I just put in the request for that today, so I don't know when that's coming, but I'm sure when it happens, it'll be a retroactive thing. To the front end, what happens when tests are run? You've submitted your test, it's been brought into the suite. How do you see how it all works? This is new as of pretty much this week. We have a front end that's out, it's available, and I'll show it in a minute. The front page, though, shows you the current kernels for each release. The last kernel tested for each release. Now, everybody can upload their tests, or their test results, and they do go into the database, and there's a way to see those, but you don't see them on the front page. You only see the ones that are done by our auto test servers, which catch every kernel build out as it comes out of Koji. The reason for that is, if people are building their own kernels, testing things like that, we don't want the page blocked with a bunch of different information and possibly hiding the information for the actual Fedora kernels that are relevant. But like I said, there is a way to see most of that information. When you click on a kernel, a specific kernel, you will see every test result for that. So if you click on a kernel that 1,000 people have tested, you'll see 1,000 results in there. And you can go through and say, well, there were 3 people had failures here, and you can go look at the logs and see what those were, things like that. The reason that is, like I said, we want to be able to say, here's everybody's data and look at it quickly, and do we have a problem or not? There could be something that perhaps works fine in the VMs that we test in and doesn't work on user systems. You submit logs. Right now, if you submit logs once you're logged in, you go to the website, you log in, you click upload logs, I believe, and it takes you to a place where you can upload your log, and they automatically get added to the database, and you get a badge for it. There is a way to send logs anonymously, and that's going to change next week, I believe. So next week there should be a package, so all this gets packaged, and it's not just a Git tree, and it will automatically submit your logs at the end of your run if you choose. It's an opt-in, it's not an opt-out. And you have 2 choices of opting in, either as anonymous or as a logged in fast user. So, let me see. Let me see how I can put this on the other screen. All right, so this is the front end right now, and this is going to be really awkward. So I'm going to look over here to see where my mouse is. All right, hold on. There we go. All right, so there's the front end, and you can see here's a 22, 21, 20, 19, and the latest kernel we've tested for each of them. Right now they're all passing. There is this one test we have, and it really should probably be disabled in the test week for right now, but I think there's a race condition in it. So occasionally you will see a fail in cache drop, and if you do, don't get paranoid by it. But occasionally you'll see a fail on here because of that, and we look into that. So you can go to any test, and you can see logs. The logs are not incredibly verbose right now, but for a pass, it's not a problem at all. If we go to one that we know is failing, this one had a failure earlier from cache drop. So I click on the kernel. Look, there were 2 passes and a fail. So what was that fail there? And then we can quickly look at this and see, hey, it failed the cache drop test. Okay, I know that that's a problem, so I'm not going to worry too much about it. But we do need to fix the test. We also have some nifty statistics. I'll show you. These are the number of tests that have been run, the number of different kernel versions tested, number of architectures tested. We don't have any ARM tests right now, so if anybody's running ARM and wants to test for us, that would be great. We're trying to get some VMs set up so that we can test ARM in those VMs. But right now we have nothing. And if you want to write architecture-specific tests, that's acceptable as well. If you need to write an ARM test, just make sure you're running on ARM. Anyway, stats per release and the number of kernels, the number of testers per kernel, things like that. And then when we go to a release, you can see every kernel that was tested for that release. And FC21 is big, 19 and 20 aren't that big right now because you can see we start down here with ROD. That was the point that FC20 was branched and we started building kernels as FC21. To upload, you can go over here, choose a file, submit, and it gets uploaded. And you can get this nifty badge. So the Git tree's here, pretty simple. It's fedorahosted.org, kerneltest.git. Also, there was a blog post today which goes through how to run the test, points to the Git tree. There's documentation.txt in there. It's very easy to read through that and determine how to write a test. The biggest thing, we've seen people say, hey, I've got this kernel bug and here's how I reproduce it and it's easy. Write a test for us. Write a test. It makes it easy.
So does cache drop fail a lot?
On
Does
auto,
it just fail on my laptop?
so on auto test, it failed a lot when it was in the startup, because it's in startup.
Okay.
So there was a lot going on at the same time. I put in a sleep 15 on that system, and it failed much less. So it seems to. I mean, it depends on what your system is doing.
The current theory is that it's basically a race condition, and that the test case drops the caches,
Mhm.
by the time it goes to check that they're dropped, your system's
Sure.
already holding
Doing
up some
something
stuff
else.
back in, especially if you have Firefox running.
Because
right?
it's just looking at how much is in the cache.
Yeah, I forget exactly what it's doing, but it's not really a concerning failure because it's not crashing your kernel, but it's not doing what it should do.
Right.
So,
But I think it is doing what it should do, and just because of
Yeah,
the
And
range.
it's just a perfect problem.
Yeah, it's right. So, summary, like I said, it doesn't take in-depth kernel knowledge, and it doesn't even take C knowledge to be able to write tests for the kernel. If you see something that's failing, it's easy to write a test case and reproduce it if you can make it fail consistently and reliably. The framework is simple to understand. Like I said, I really covered pretty much all of the details of the framework in 20 minutes. So it is a very simple framework to understand, but we have documentation.txt there if you need it. Running the test suite regularly is very easy to do. It takes right now less than a minute. As we get more tests, so we spend a lot of time kind of working on this, the harness, the framework, and the front end, and now a lot more time is going to be spent on getting tests into the suite. As we get more tests in, we expect that's going to go up, but it shouldn't take more than 10-15 minutes ever, and probably will not put much load on your system. Things that take longer than that go into a different directory and won't be part of the default. Right now you only get a badge for running the test suite once, but there are badges being added for more than one run. So if you're running it just out of habit, you'll get more badges later, whenever that happens.
I uploaded the test. I haven't got the badge yet, so is it available right now?
Did you logged in and uploaded?
Yeah.
Oh, I'm not sure. I'll have to talk to Ralph and find out why.
Okay.
So if you're logged in and uploaded, it should have worked.
Peter just got this a minute ago.
Yeah,
Yeah.
totally happened.
Help us expand our test coverage. The test suite is only as effective as the tests that are in it. So, and right now, it's honestly the most effective part of it is the fact that we're auto testing everything right now. We've got a couple of tests that are worthwhile, but we really need a lot more tests.
I got it. I think it's just it doesn't show up on the page.
Oh, and you never know the order that they're going to show
Yeah.
up on.
Yeah.
So, questions?
Yeah, I've been reading, like I said to Josh, they have, I know right now, 6, 7 test cases now for running. What do you expect? The people need to run all the tests for you gives, I don't know, what do you expect for the people run? All tests, single tests every time?
Oh, just default.
yeah, just the default.
Yeah.
So when you just call run test, it just runs whatever's in the default category, which is 6 or 7 tests, and then as we get new tests added, we'll look at them and say, okay, well, does this take 3 hours to run? If so, it doesn't go there.
Right.
Does it take 20 minutes? No, probably not. But does it take 30 seconds? Yeah, we could.
Yeah, so the goal is to keep the actual test suite, the default test suite, under 10 to 15 minutes for all cases. There are more extensive tests that can go in another directory, and we can run those. And our auto tests will run those as well. There's no reason that we, by putting them somewhere else, it doesn't mean they won't get run. It just means that you might not have the coverage, you might not have the number of users running those as you would have if they go in default. So we also have some tests that where we have a place to put some tests, which could be somewhat destructive. Those tests will be run on auto test.
So how do I run other tests? I mean, by default it runs the default tests. So there are, I see multiple directories like stress, performance, destructive.
Right, so that's how sorry, I probably should have covered that. That's how a test goes in. What the default harness does is what the test harness does, if it's running at the default case, it goes into the default subdirectory and then goes into every subdirectory in there and runs runtest.sh.
Okay.
There's different options you can pass
So-
to the high level thing. It's a script, you can just read it. I forget exactly how to do it, but you can tell it to go run the stress. Or there's really nothing in performance right now because you want to explain why there's.
Yeah, so on the performance testing side, we actually have another server set up that's going to be doing performance testing. And we were using that as the front end as we were developing the front end, and we've just put a lot of resources into that right now, and that hopefully will switch and we'll have some more performance testing actually happening before the end of the year.
It's tricky too because you can't, depending on what performance you're talking about, I mean, if you're running like some industry standard benchmarking type stuff, right? You want the box isolated. You don't want it to be running Firefox and GNOME and all this other stuff that you're normally doing on a desktop. So it's not something that we really expect users to run. But we are interested in performance numbers, and Justin's been working with the performance team within Red Hat to kind of get some of those isolated things built.
Yeah.
They don't like our Rawhide kernels because they have debug options on. But they've been using the Rawhide no debug, right? That's pretty much.
You're
doing
pretty much.
special build.
Well, they're using Rawhide no debug. It's just because their framework pulls in an internal build server that they get built.
It's basically the same thing. But yeah, I mean, we're doing performance testing and they're doing comparisons and stuff like that. But we haven't really had any actionable items on that yet.
That's one of the things with the performance testing is we have to say, all right, we're only going to do it on Rawhide. That makes sense, right? Performance regressions are less likely to be stable. But so we run it there. It has to be run on one arch at a time, one virtual machine at a time, with nothing else happening on the system. We need database for baseline, and then anytime you do an update besides the kernel, you have to rerun your last baseline to make sure, hey, glibc updated, is that causing issues with performance? So you have to, it's got to be a much more controlled environment than a regression to what test suite does. And there's more code that's got to be written around that. But if you write a performance test, you'd be glad to take it.
I know Owen Taylor yesterday showed me the stuff he's doing with upstream and GNOME. He was asking in my talk about the debug options and how it's terrible for performance. When I talked to him, he wasn't necessarily saying when you sit down and use your laptop that it's noticeable, but he's saying his continuous integration to continuous delivery stuff he's doing upstream, they're tracking performance of the GNOME components,
right.
And it's extremely noticeable when they run it on Rawhide because everything's way slower than what you would expect.
Right.
And he's got these little graphs to show it, so performance is also a relative thing.
Yeah, but I mean, as long as you're doing it against your last version, right? You've got a baseline, and you can continue working off of that baseline. And anything changes other than the specific thing you're trying to test, you have to redo your baseline. So that's the other thing we've got to figure out. Because we turn off debug for RCs.
Yeah.
So we need to make sure that those are either not tested or thrown away, or that we only compare those with other RCs. So maybe we've got 2 lines for it, and I've got to figure out exactly how to do all that code. But that's not doing the actual test. That's just in how we report it and how we.
So I have a question.
Yes.
I know it's quick, but how fast from the time Cody finishes the build to the time it grabs that build, and is it dependent on, since it's per release, it's dependent on that build hitting that tag, right? Or do you just pull from fed message?
Right, we pull. So fed message says the build is complete against that tag.
Yeah.
And as soon as we get that fed message, the get or the auto test will boot up that virtual machine. If it's not running, Rawhide is different. It reboots it because it runs all the time. But for a regular release, say when this F20 build kernel build's done, before you get the email, it's already got the fed message and it started the system, and then the kernel that was built is actually written on NFS for us. So when the guest starts up, it looks to find out which kernel version it's supposed to be testing, grabs that kernel, and that's really what takes the longest time because those servers are not necessarily where the Koji repository is. So 2 to 3 minutes for it to download the kernels and then reboot into them and run the test.
Is it copied to NFS?
No, because nothing else will use it.
So it's pulling. Oh, yeah, okay, I see what you're saying.
Yeah.
The reason I ask is because some of the questions, not just Owen's, but other people have asked me, well, how can we make the Rawhide kernel more stable, particularly in the early releases? And one of the things, after thinking about it a little bit over the past couple of days, that I would like to do is be able to not rely on it, but definitely use this as a guide, right? So people grab the kernel, they run it, they're watching on fed message and they're testing it on their own systems and kind of doing what the auto test harness is doing to a degree. Maybe they wait for the auto test results to show up, but then they run it, and if we can use that to judge how many times it's failing in the test cases, and if it's a bad kernel or if other things, right? Even people can even send emails. But I want to be able to go in and have some kind of heuristic that says, okay, I did this build this morning. this number of people and this number of test case runs were done. Is it good? Is it bad? And if it's bad, I want to go in and actually just be able to untag it from Koji so it actually doesn't go in the rawhide compose.
Right.
And we aren't doing that right now because right now we're relying on that rawhide compose to get it out to the users. So the more tests we get and the more people we kind of get voluntarily running these extremely fresh kernels to let us know if they're broken, the more we can kind of save pain for everybody else that isn't either set up to do it or it doesn't feel comfortable doing it and things like that. Because yeah, I mean, I've done several rebases since we've been here, but I haven't built it in Koji because I haven't been able to test it myself, and I don't just want to push it out to people and say, hey, how's it working? So yeah, relying on this, relying on other people testing, will really help everybody in the long run, but it'll certainly help Justin and I know when we can do that untag operation or when we can just let it ride and see what else happens. So.
We've had to, that's one of the reasons cache drop needs to be fixed. We had an issue 315, I think, an early RC 315, where 32-bit was failing.
Yeah.
But because cache drop always fails, I saw the fail and really didn't think anything of it. And honestly, I pay less attention to 32-bit. Just on my own system, so I didn't really think anything of it. I just assumed it was cache drop. And after other users reported the problem, I realized that maybe we should start paying a little bit more attention to failure, so we're clean up cache drop. Or even disable it for now if we need to. The idea is your default test suite should always pass. And like I said, that's why I'm going to put somewhere else. If you've written a test for a bug that is failing, that's going to go in another directory to make sure that we run it all the time and we're aware that yes, this is still failing, but we're not going to put it in the default where you look at it and say, oh, this is a regression, because it's not a regression from what's there now. Anything else?
I do actually have a couple of questions. This seems a bit specific to Fedora. Do you collaborate, or are there other similar activities?
There's nothing specific to Fedora about the test suite itself.
Definitely, but I'm thinking that probably the subsystem maintainers do maintain their tests for, say, their file systems or, I don't know, USB stick.
Right.
I think, and other distributors as well. We're definitely not the only user of Linux kernel. Ubuntu uses it or Debian. Do they do something similar, and would it be possible to cooperate?
There was some discussion about that on the Kernel Summit mailing list, and a lot of people are doing a lot of different things. Nobody really has any sort of a unified way to run things. With a lot of this, there is a lot more test development that's happening upstream, and those are things that we'll be able to pull in and say, hey, I want to run this or I want to run that. But the goal is, once we have a little bit more coverage, I definitely want to approach the other distributions and say, hey, you can use this, or can you give us share test? Even if you use a different framework, perhaps you can share test. Some of the frameworks that I've seen out there that other distributions have used for their test bits are very in-depth frameworks, which make it very difficult to run that test anywhere outside of that framework.
These tests, are you supposed to run them as root from within the system you test?
Yes, you should. But if for some reason you run it as a user and not as root, it just ends up skipping a lot of tests.
So I'm thinking about makes it a bit difficult to test for some, like, how would you test suspend and resume? It's not possible to do that from within because you cannot resume the machine once you, and it would be possible.
You can do that.
You can do it.
You can. It doesn't exist yet. There's all kinds of other tests that you can easily do, right? Like, does my backlight work? Does my video card actually show me something on my screen? Right? There's a lot of stuff that you actually need a human to give you input, and an automated test framework isn't gonna. I mean, you're not gonna just magically invent something unless you rig up something like a webcam staring at your computer to let you show these things. And it's not really. I mean, yes, suspend, resume, backlight issues, video driver issues, sound, right? Things like that. Those are all the really hard things to test that an automated harness isn't going to do. And we know that, and we're not expecting people to have awesome tests to just throw in this thing and magically solve that. if they do, I will buy them a bottle of whatever they like to drink.
Noted.
But back to your point about sharing test harnesses or collaborating with other distributions in the upstream kernel, Intel actually has, I think it's like 3 or 4 guys now, but they have this thing called 0 Day that they tested. They actually run it against Linux Next, and it is probably the most comprehensive kernel testing that exists today, but it doesn't catch everything. The way they do it is they have, for every single commit, not build, but every single commit that goes into Linux Next, they'll build a kernel, boot a VM, see if it boots, and run some stuff. And then now, off to the side, not exactly part of 0 Day, they're doing performance testing to see regressions and things like that, which is amazing, right? That's far more comprehensive than what we're doing at the moment. But we don't need to duplicate that because they're already doing it. And when we talked to them about it, they said, yes, we're doing this. That's basically the gist of what we're doing, but we can't tell you how or why or what we're using to do it. So they won't share.
Obviously, they're also
Thinking
using
that
a lot of hardware.
I'm using a system with file system driver which breaks a lot. Like in last 20 releases it broke like 3 times to the point that when you mounted the image the kernel was panicked. And I was thinking that I should probably write a test somewhere. It's easy to test. You just essentially create an image and mount it. And I was not sure like where is the correct place where I should put my testing.
Yeah.
And I'm now thinking that is this Fedora kernel testing repository the correct place to?
You can send it to us, and if it's something that's useful to other people, we'll certainly keep that in mind and forward it on.
Yeah.
Right? I mean, we'll grab it either way because if it's useful for Fedora, we can run it even if nobody else thinks it is.
Right.
So yeah, I mean, we're certainly there to help people get it to the correct location.
Okay. Thank you. So I'm hoping to kind of shop this around a little bit at Plumbers Conference as well and get some exposure to other developers.
Yeah.
So that's in October.
In Düsseldorf.
Yes. But so the only thing that's actually Fedora specific in it right now is the front end. Now once the auto submit and that bit goes in, that's a Fedora specific thing, but I'm doing it as a hook to where it doesn't have to be. So the run test is only going to call a commit hook, and then we've just got to configure our RPM that sets up the commit hook.
How about stuff where you, which you all can't really run in? I'm testing right now a scenario where I kick off the tests and they should end in a specific amount of time. Just there are a couple of bugs which you encounter like once a week. If you have a long-running machine, and sometimes they happen, sometimes they don't. Are there any efforts to cover that so you can have like something that just watches your system for a specific event? I mean, if it's oopsing for instance or something like that.
We haven't written any tests like that now, but there's a place for them in the framework.
Mm-hmm.
And once we have those tests and put them in the framework, we will run them on our auto test systems. We don't have a problem with that. The problems with some of those, well, there's a couple of problems with that specific type of scenario. And that, is it a test that has to be run exclusively? No, we probably need to thread it off somewhere and let it run, and then that way we can run other tests at the same time. And if it,
I mean, there's stuff where, for instance, Wi-Fi works for 3 days and then suddenly there aren't any packets getting through. I don't get any error messages or stuff like that.
Right.
I mean, I don't have this stuff right now.
right?
But I've had machines in the past that were flaky in some kind of regard, whether it was the hardware or firmware, I don't know.
So
Stuff like
this kernel test isn't necessarily a replacement for Bugzilla, right? And
Yeah.
if you have the ABRT tool installed and you're getting oopses, that's still going to report bugs to us. Where this comes in is if you have something that you have this situation, you have the bugs reported, and you have a very easy, not very easy, but if you have a way to recreate it in a
reliable
simple
way.
fashion,
Yeah.
you know,
Trigger the bug.
right, and if it takes 3 days, you can still send the test and say, hey, I know this shouldn't probably be running the default thing, but I can run this reliably and it'll take 3 days.
Right.
And we can put it, we can create a new category for long-running tests, or we can put it in stress tests or something like that. But again, I mean, it's not a replacement for Bugzilla because hopefully it doesn't oops at all.
Yeah.
If it does oops, because it does, then the ABRT tool should still be reporting bugs for us, and so it should be tracked at a bug level in Bugzilla, right?
And hopefully we'll also have changes to the retrace server soon that make
Yeah.
it more reliable for us finding things too.
Yeah.
But I mean, a long-running test, the only thing you have to really worry about with a long-running test is even if we auto-run it every time, stable kernels tend to be about once a week. So nothing's going to run longer than that.
Yeah. It's
Go on vacation time and back to your computer.
Yeah, I mean, it's a problem with the release frequency Upstream has right now too, right? Greg Crow-Hartman, the stable maintainer, and obviously he maintains like half the kernel. He's really, really, really proud of saying how fast the Linux kernel community develops code, right? We can push 10,000 changes per release with no breaks, and breaks in development, not breaks in function. And we're awesome at it, and they are. To his credit, and the rest of the kernel community, they do a really, really good job of doing the best and developing fast and trying to keep things working. But that makes it hard to consume what they're producing and lets you start skipping releases. And then, in my talk, I covered why that tends to be bad in terms of interaction with them. So, yeah, I mean, I know people who install Fedora 20, which was like 3.11 at GA, and they've never updated the kernel ever, just because they don't update. And so they report a bug, and it says, yeah, this takes 2 weeks. And I look at the version number, and I'm just like, sorry, can you test it on a new kernel? And then they do, and it's like, oh yeah, it was fixed like 4 releases ago. So it's all subjective, and we'll do our best. That's all I can say on that one.
Well, that's just today. Like I said, I just committed 3.15.9 and it's building right now. And Greg said that there will be one more 3.15, and after that, Fedora's got to go to 3.16. Well, I mean, realistically, we're going to look at it because 3.16 hasn't had a one stable yet. So we'll look at it and make sure first.
Yeah.
And if we need to backport patches to 3.15 for a little while, we can do so. But they move quickly.
Really, the benefit for the kernel test harness is in Rawhide. I mean, that's the main place where it's going to help us the most. Because it's going to catch bugs while that kernel's in development. Once it hits a release, we're still going to run it. We're still going to make sure there's no regressions. But if there were regressions, we should have caught it in Rawhide while it was being developed.
May I have a question?
Yeah.
How different are kernels in now F21 and Rawhide? Are there differences or?
Right now, in terms of what you can download from Koji, they're identical. They're both 3.16.0-1 or something like that. When I get back home next week, Rawhide will start going to the 3.17 merge window, and then they'll diverge from there, just naturally based on that kernel version.
Go into package DB and assign the MBT package to me because I accidentally assigned it to you.
Okay.
Good job.